So we're continuing integration by parts, and this time around we're introducing examples of arc functions and um, logarithmic functions. And those are the ones that we haven't discovered yet, basically. So a lot of these material, not until you do some hands-on, is the memorization part of this. It has a significant amount of memorization into these things, and basically seeing how things work until you can come up with your own material, basically, and how to integrate by part and do the integrations by parts. And so the first time around, I'm looking at this. I don't even see product inside the integral of arctan of x dx. Um, so, but if I compare to here, it seems like if I choose that one to be u and this one to be dv, then I may get somewhere, basically, because I know how to take the derivative of arctan, because over here I will need a derivative of arctan, and I know how to find the antiderivative dx, basically, and integral of integral dx. And so basically that's my first thought. And again, so you have to have some intuition into it that arctan is going to be integration by parts, or you basically by try and error you figure it out, and then at that point you look at it and you see, well, I don't see anything multiplying arctan, so dx should be dv, basically. And so let's set it up again. My rule of engagement is put the u first, equal to arctan of x, and then dv equal to dx, then find du. Well, I can find du because I know how to take the derivative of arctan, and that is 1 over 1 plus arctan of x is 1 over 1 plus x squared, and dx, and then antiderivative of dv, which is antiderivative dx, is going to be just x. So v is going to be x. Again, these two multiply, and integral of the second line. And over here, what I get is x arc tan of x minus this entire thing, x over 1 plus x squared dx. Okay, I'm not done. Do I know how to integrate this one? Yeah, I kind of know. This is a u substitution. So I did an integration by parts. Now I ended up with a u substitution. And what should I choose for u? This would be a good option. So if I do u equal to 1 plus x squared, and then du is going to be 2x dx. So this integral becomes x arc tan of x minus 1/2 of 1 over u integral of, du. And when I integrate that, I will get natural log of u, so x arc tan of x minus 1/2 of natural log of absolute value of u, which absolute value of u is going to be 1 plus x squared plus c. I skipped this step, basically. I didn't write negative 1/2 of natural log of 1 plus x squared. Natural log of absolute value of u. I wrote 1 plus x squared, basically. Okay, so that's that. Now let's do this problem. Again, these type arcs, arc functions and natural logs, I don't know any other way of finding their antiderivative, basically. And over here, again, any other major method of finding antiderivatives, basically. So in here, what do I do? Again, I'm suggesting integration by parts. And so again, you want to choose this one to be u and this one to be dv, because there's no other function I can see visibly. There's the one function that sits by dx, basically. And again, you will have u equal to natural log of x, and dv equal to dx. And so du is going to be 1 over x dx, and v is going to be x. And then again, these two multiply, so the answer is going to be x natural log of x minus the integral of the second row, which is 1 over x times x, which is 1 dx. And so it's going to be x natural log of x minus antiderivative of 1 is x plus c. So now I have, not only I have the antiderivative of arctan, I found our antiderivative of natural log of x. So, one other question that people ask is that, so how do I do antiderivative of x natural log of x dx? And so for this one, again, a lot of times all the beginning problems that we did with x sine of x or x cosine of x, or it could be x tan of x, we chose x to be basically u and the rest to be dv. In this case, because if I choose x to be u, taking antiderivative of natural log of x either needs memorization or it makes it difficult to do. I'm suspecting that it should be the other way around. And so you can try and see, there are methods that you can mess with it, makes it a lot more complicated. So the best method is just to go with your instinct and choose natural log of x as u, just like you did over here. So that exponentials and sine and cosine are different from natural log of x and arctan of x when you're using the integration by parts, basically. Here, that one is going to be u, so this entire thing is going to be dv. So u equal to natural log of x as usual, and dv is going to be x dx. So du is going to be 1 over x dx, and v is going to be x squared divided by 2. Now, again, these two multiply together minus the integral of the second part. So the answer is x squared divided by 2 natural log of x minus integral of 1 over x dx times x squared divided by 2. That gives me x divided by 2 dx. And so it's x squared divided by 2 natural log of x minus 1/2 comes out, x squared divided by 1/2, so x squared divided by 4 plus c. So this is a good comparison of this type of integral versus the other types that we have done so far. Now let's move on to integration when more than one integration by parts is needed. Another thing that I wanted you to notice is that you did integration by parts, and then you did and you substitute right there. Also, so it can be a mix of those, and then sometimes it's the other way around is the easiest way to basically come up with these answers.